Hey everyone, this is my Centipede final project. I'm going to run it and then walk you through some of the features. I'll have this screen open right here, just as a reference. So we begin the game in attractor mode, just as it states over here. I don't have two-player mode implemented, but if you press the 1 key, I'll give you a demo of the sounds and the overall game as you play it. So we do have the Centipede beat. We have firing sound. I'm just going to play a little bit to demo all the features. Alright, and then one more thing. There we go. Now I will mute the sounds. There we go. Alright, so as you can see the critters are moving just as the reference game. And also I demoed it. The mushrooms do the regen state. So I'm on my final life right now. I don't have a high score, but if I can get one, I can demo the high score entering the initials as well as saving to a file. Alright, so I'm approaching the high score. Let's see. Almost there. Alright, so as you can see the high score is automatically updated anytime we score now. Alright, and now I will get my player killed. So it counts up all the mushroom points, displays the game over screen, and now I can enter my initials. And there we go. That's a placeholder score that I have in there right now, but I can show you how that's all done. Alright. Alright, so in terms of game features, we do have the blaster with basic sounds, movement, and death, single bullet at a time. The AI mode and attractor modes. The mushrooms have multiple states, and the scorpion poisons them. Once you die, the mushrooms regenerate. Centipede has the sounds and movement. All of the critters are there. Attractor mode works. The pattern isn't exactly how the original game has it, but it's pretty close. Alright, and then also these high scores are written to a file. check that file out. Right here. So as you can see, the 2 high scores that I just entered, one of them not so much. This file is read in and saved out on launch and on close. So there we go, all those high scores that I just entered are read into the game. Really quickly, let me change this to use the actual value. There we go. Okay. Alright, so scoring is also implemented with the HUD, and it displays lives and high score correctly. I use the strategy pattern all over the place, and I'll get into that in a moment. Let's see. Observer pattern is used. Yeah, too numerous to list. Factories are everywhere, as well as singletons. I do have the Centipede subclassed from the Centipede segment right here. So we have the Centipede head and Centipede body, and those simply have different sprites. Most of the code underneath are very similar, besides the movement code. Mushroom field, I have an array with all of that. Let's see what else. Wave control, I do read that in with a text file. Right over here. So I'm using JSON CPP to parse this, and it's really easy. You could write like an editor or of some sorts if you need to, but the format is really simple. Player does have all these different states combined. The text does have a flyweight pattern. Sound manager is again using a strategy pattern to enable muting, and high score manager keeps track of the high score file. Alright, so now we can dig into how it all works. Alright, so this is the class diagram that I have. A lot of these over here are the factories because they don't link directly, but many of the objects link back directly to game objects. So I'll just start with the leftmost, which is the Centipede itself. Let's see. So the movement system I have for that, it's all using the command pattern. So if I can find it, we have one moment. There we go. So we have Centipede segment commands. That's what I call them, at least. And each of them, they handle a little bit of movement, and each Centipede segment has a stack of these commands. So the head actually makes the decisions on what command to make next, or to pass down the list next, depending on if you're the edge, or if a mushroom, or poison mushroom, or what's happening. I like this system because you can add commands really easily if you need to expand on it later. So getting down the basic left to right movement was nice, and then adding like poison mushroom handling and maintaining like the player area was super easy. As for the body segments, all those do they get the last command from the head and then repeat that until it's complete. And then once that's complete, they pass it on to the next segment. Alright. I'm also using the command pattern for the blaster. So we have a whole bunch more commands. Some of these are used by the keyboard, some of these are used by AI. AI uses the diagonal movement mostly, and then you have like a fire command which just tells the blaster to fire. This again makes it super easy to add more commands and tweak it later. So yeah, right now I just check if we have WASD movement or if we're hitting the spacebar and we can fire a bullet. Let's see, what else? Alright, so as for the critters, let's see. So we have basic implementations of each of the three other critters, so flea, scorpion, and spider. The one that's most interesting is the spider, because I'm again using a command pattern to control it. That made it super easy to basically script its movement. After every time we complete a command, we randomly choose if we want to move vertically or move diagonally, and then we can just keep going between those two. Other than that, I have factories in place for basically every critter. So let's just look at a simple spider factory, and these are all pretty much the same. They maintain a stack of whatever critter they are, and when you request a new critter, it'll check to make sure that we really need to create a new one. Otherwise, we can just reuse one. Alright. That's about it for critters. Let's take a look at the mushroom field. Alright, so mushroom field, very basic, not even a game object, but it handles the creation, destroying population, and removing mushrooms when a player shoots them or they get repaired. So it's just a 2D array of these mushrooms. The most interesting part about this is the repair. I will get into that later, how that works, but it's pretty nice. Alright. Also, the mushroom field isn't a singleton. It's actually passed around in the game controller, which I'll get to later. That's to make it a lot easier to go from wave to wave or screen to screen. Alright, so let's see. Quick look at explosions. There's an explosion factory, but all an explosion does is create itself and then set an alarm to destroy itself after 0.25 seconds. It's a very easy way to just get self-destructing objects, and it looks good, and the factory takes care of creating a lot of these at a time. Alright, so now we have, derived from the game objects, we have text, which I'll get into that in one moment. Before that, let's take a look at the player controller. Actually, let's take a look at the input controller. So this is using the strategy pattern. So it's a singleton as well. So each controller is setting what input handler or what handler to use. These aren't created or destroyed by anyone. They're created right here in the controller itself, and then all you do is pass in an enum to decide which one you want to use. So input controller, say you want to use the AI controller, which just makes them bounce around the screen. All you do is pass in input handler AI. It sets that handler to the AI handler, which over here is implemented to simply count up and then decide what its next move is, and then keep repeating that movement. So now if you want keyboard control, now you handle it yourself. So you just check if the keyboard key is pressed, and then you return the proper blaster command, which I described earlier. Simply sends the command back over to the blaster. So this same type of controller handler, like strategy pattern, I use all over the place. It's actually super nice. It makes it really easy to be able to switch between a whole bunch of different options really quickly. As you can see here in the diagram, they all derive from input handler. I do the same thing with the score handler, which I will get into later. There's also sound handler, which I do the same thing. It's the strategy pattern. Take a look at that real quick. That is how we mute the whole game. So we have the sound controller, we have a basic sound handler, and a null sound handler. If you choose the basic sound handler, we simply decide what sound we want to play, and then play it. Now if we choose the null sound handler, we do nothing. So no sound will ever be played. There's no ifs, makes it nice and clean. Alright, and then I'll show you the score handler. So again, we have a score controller, which decides between either a basic score handler or none, which is the null handler. Basic score handler will basically you call score controller.get get handler, and then add score, and then you look at this enum, decide what score you want to add, and this takes care of that. This also updates the high score itself and the HUD. And of course the null score handler doesn't do anything. So I use the null score handler when we don't want to increase the player's score at all, which is on the high score screen. Alright, let's see. Alright, so let's look at fonts real quick. Alright, so text is derived from the game object, and then we also have a sprite sheet and a font. What the font does is maps over this image. Maps over this image, which I've also embedded the player sprite in there, blaster sprite. It maps that to different keyboard keys. Of course, you know what this is, you provided that. Alright, and then I added a little bit onto the glyph and text classes. As for glyph, I added just basically storing what character it is. That makes it really easy to read back later what we've actually typed out. Okay, over in the text class, we derive from game object. Alright. So this handles basically all of the heads-up display. And now I've also added set dynamic, set static. It's if you want to have text entered or not. We only use it in one spot when the player is entering their initials. So when text is entered, we make sure that they don't press backspace. If they do, we'll delete the character. And then, yeah, we'll handle enter key that will save their high score and put it into the JSON file. So this is actually using the flyweight pattern, which the glyph is a really lightweight representation of a character. So back over in text, we maintain a list of glyphs, and then when we want to draw our text, we just iterate through them super quick. Alright, that is basically all of the low-level stuff. I described blasters, bullet factory, just like any other factory, command pattern, all the critters, what else? Explosions in factory. I'll take a look at high scores, the HUD controller, as well as player controller. Basically a bit more of the high-level controller classes I'll take a look at. Also wave loading and cycling. Alright, so I'll just close this for now. So the heart of the game is in this game controller right here. So it's not that long of a class, but it uses the singleton pattern. Anywhere where you see controller, that will most likely, if not always, just be a singleton pattern. Whenever you see handler, that will be the strategy pattern. And of course command is command. So when you first start the game over here in main scene, all you have to do is set the state of the game controller. So we have a few to choose from. I don't have two-player implemented right now, but there's a code there to handle it. If I'd work on this later or something. But right now we just set it to display the high scores, which is the main screen. Alright. Okay, so when we do that, we instantiate the singleton, which is the game controller, which registers for input and then also loads high scores and wave data. It also creates a mushroom field, but that's just for the initial state that it's in. When we change states, this mushroom field is destroyed and then recreated. So, alright, so I'll get into the high score loading right now real quick. Alright, so here we go. So we have the high score controller, and this is of course a singleton. It uses the JSON CPP library. We can load from a file, write to a file, and then set all the different high score stats. Alright, so loading from a file is pretty simple. All we do is just parse out the JSON and then resize to a maximum of 7 entries, just in case the designer enters more. And then we set our high score to whatever is the first high score value. Alright, that's loading. I'll get to writing in a moment. Writing is super simple. Okay, so when the player gets a new high score, all we do is call this. A high score then is registered, and we keep updating that. So then later we can check for this new high score boolean, and then if this is true, then we can navigate over to the set high score initials. and this reads from those glyphs and the text input, which I showed you earlier. What this does is insert the initials with the high score, and then it sorts it in reverse order. Of course, we resize again to make sure we're at 7 entries, and then we navigate over to the display high score screen. I've implemented this toString in a few places just to make it easy to talk to the HUD. What this does is take the high score value and then pad it with the proper spacing or zeros that's required that the original game has. And of course, since we have JSON parsing out the high scores table back up here, when we want to write this to a string, all we have to do is iterate through it and then convert the values. Okay, so that's a pretty nice system to just grab strings and then display them on the HUD. Alright, so back over to the game controller. So after we load the high score file, we also load the waves from a file. And that was a cat jumping around. Alright, so I'll show you Wave Controller. There's another pattern that I use here, which is quite handy. So the Wave Controller, very basic, singleton of course, and we can load waves, add waves, get waves, move on to the next wave, and also reset, which sets the current wave back to 0, so we can cycle through them easily. Alright, so we just have a vector of waves, and the first thing that we do back over in Game Controller is load waves from file, which I have this wave info loader handling. Didn't really need this wave info loader, but it's there, so could have just done this in the Wave Controller. But just as the high scores does, it reads in from a JSON file and then parses it. The interesting part about this is that we have a wave builder, which is a nice pattern. So all this class is responsible for is creating waves. This is a singleton, and what you can do is set different values that you read from the file, and then once you want that wave, you just do get wave, it returns it, and then you can continue on and build a whole new wave. What I do with these, I add this to the Wave Controllers list. So then once all those files all those structures from the JSON file are read in, we have a vector of waves. Super easy to customize. I can load up that file real quick. See, so we have Centipede, Spider. If any of these are missing, as you can see up here in the first wave, we don't have any heads, we don't have the flea, and we don't have the scorpion. Then they are just defaulted to not spawning. So no matter what, if the designer forgets to write them, well then they just don't spawn. Alright, so that's Wave Info Loader, and then we can take a look at what a wave is itself. The wave is a pretty hefty class. There's a lot to handle, so we do inherit from a game object with the wave. Okay, so we set. Let's go back to Wave Controller. Alright. So I'll actually get back to Wave in a moment once we continue on with the game controller. So of course we create a new mushroom field, and then we continue on with the game controller. Let's see, how long have I been talking? 30 damn minutes. Okay, so quickly going through this, we subscribe to the key pressed event. That way we can mute the sound anytime we want. This also allows us to handle, unlike how the blaster gets its input, we can handle single key presses, which is nice. It doesn't, just as the text does, it's buffered input compared to unbuffered. So depending on the state, we want to do different things. If we're playing, then we can mute the audio with the home key, and we'll actually restart the audio. But home mutes the audio, and then once we're on the high score screen, we select player mode, which checks if we press the 1 key or 2 key. 2 isn't currently implemented, so please don't press it, but it's there for later. Alright, continuing. Let's see. Alright, so when we set a state in the beginning of the scene, we set it to display high scores. First, we reset the scene, just in case there's anything that's happening. We stop all the sounds, we destroy everything that's in the previous wave, and then we reset the wave back to 0. We also have alarms, which I will get into later, what they're handling in the controller here, and we reset those as well. Alright. So then, depending on what state we chose, we simply call the function to handle that. So display high scores here. We set the score handler to none, sound handler to none. We initialize the mushroom field. We don't care about lives, so we set the player to have infinite lives, spawn a new player, set them to the AI input, and then load the current wave data and pass in a pointer to the mushroom field, which right here is the observer pattern. Because a lot of the different objects in a wave need access to the mushroom field's data. We also tell the HUD controller to display high scores, and I'll take a look at the HUD controller real quick, but this is kind of a hefty class as well. So upon instantiation, we just create a whole bunch of text. None of it's being drawn. After that, we have a clear HUD function, which would just wipe everything. Okay, so then we display high scores. It sets the text as necessary, and reads in the data from the proper controllers. If we were to switch over to playing, then we'll set the HUD as necessary again, and we'll do the same thing when we enter a high score. Alright, so the only direction that the user can go from the high score screen is to the 1 player mode. So once we do that, we back up in the set state, we reset everything, and then we set the score handler to basic, so now we'll start handling the score again. We'll reset it to 0 just to make sure. Sounds basic, so we will get some audio feedback. Reinitialize the mushroom field. We no longer want infinite lives. We spawn a new one, and then we set them to keyboard control. And then we do very similar to what we did with the display high scores. Alright, so what's interesting about this is what happens as the player dies. So upon death, they call game controller death. What this does, this handles the regeneration of mushrooms, and it uses alarms to do so. So we pause everything that's happening right now on the wave, and then we set an alarm for 1 second in the future to start repairing the mushrooms. So then every 0.1 second we will repair the mushroom field, 1 mushroom at a time, and once all of them are repaired, this will return true, which then checks if the player's lives are 0 or less, and depending on that, either continue the game or set a new high score. Yeah, let's see, what else? That was quite a lot. I do have an issue right now, which I couldn't get to fix, but so the wave data, for some reason, it throws an error on the exit. Something's being deleted too quickly when I create a wave, but it doesn't affect the game when you're playing, only when you exit the game. So let's see. Are there any other things that I need to discuss? Alright, so alright. Let's see. Alright, so I think the feature that I didn't implement, one of them, I'm not sure if there's any others. I've been spending a lot of time on this project, actually in the midst of the longest all-nighter that I've ever held, currently over 24 hours. But anyhow, one of the features, or the only feature, I'm not sure, that I didn't implement is the text and Centipede interaction. Currently they just walk right over it. I do have an idea how I could do that. Basically, I could block out underneath the text with some placeholder object that would tell the Centipede, do not walk over here. Did not get to that, but I think my implementation of Centipede is pretty close to that Flash game, so it's not too bad. Something else that I would have liked to work on is smoother rotations. Oh, that also reminds me, the critters don't flip in the correct direction. Very minor, but something that I did not get to. What else? Game modes are all there. Yeah. Oh, maybe one more thing. Sometimes the Centipede movement gets a little funky. I think I have an idea why. It's due to the commands completing at different times, and then they kind of offset each other. So it's kind of weird. It's not too difficult if I were to spend more time on it, but for what it is right now, I think it works pretty well. Let's see, anything else? Coding practices. I think I maintained a pretty good coding practice all around. I was kind of iffy to dive into singletons just because of a whole bunch of stuff I read on them and how you can abuse them, but I actually really like them. I like the controller-handler approach. So, yeah, that's about it on Centipede. It's a great project. Really interesting. I learned a lot on this, so thanks for watching.